Okay, in this video, we will see about electric potential. Electric potential due to a point charge, which is called absolute potential, equipotential or equipotential surface, potential difference, and electric potential energy will be discussed. Electric potential. Electric potential is the work done to bring a test charge from infinitive to a point charge. For example, if a point charge Q is placed here and a small magnitude of positively charged particle, which is called test charge, at certain distance r from a charge Q, so the work done on a test charge Q naught to bring a test charge from infinity to this point is said to be electric potential. Mathematically, electric potential is equal to work done per unit test charge. Work done over test charge is equal to electric potential. Electric potential due to a point charge. For example, this is 1, 2, electric potential due to a point charge. This Q is point charge. Due to this point charge, at certain distance from this charge, there is a potential. To determine a potential at certain distance from this charge, which is called absolute potential or a potential due to a point charge, is mathematically expressed as V electric field strength due to this charge is equal to potential over R. Field strength due to this charge. This charge can produce electric field. This field has its own strength. So the field strength produced by this charge is mathematically expressed as V over R, electric potential over R. Therefore, from this we have V is equals to electric field strength times R. But electric field strength is given as E is equals to K times Q over R square. KQ over R square is equals to electric field strength due to point charge. So substitute this expression instead of electric field strength. Therefore, V is equals to K times Q over R square times R already exists. Therefore, R is cancelled by 1R. So electric potential due to a point charge is equal to KQ over R. KQ over R. This is electric potential due to a single charge. For any number of charge, since electric potential is a scalar quantity, electric potential for any number of charge is equals to, for any number of charge which is equals to V1 plus V2 plus V3 plus Vn for any number of charge. Finally, this is equal to the sum of I, which is equals to 1 to n V of I. Good. This is absolute potential or the electric potential due to point charge. The other point is equipotential surface. Equipotential surface is the surface in which the potential of a particle or a charged body is equal. This is simply a surface. For example, a charge Q is placed inside the circle. Consider a charge Q is placed inside a circle. Now, at the center of the circle. Now, there is point A, point B, and point C. To determine potential at point A, let's say this is R, this is also the radius of the circle, and this is also radius of the circle. Now, the potential at point A is equal to K times Q over the radius of the circle. K times Q, magnitude of charge, over R, the distance from the charge to the surface of the circle is R, which is equal to VA. Potential at point B from the charge is also equal to K times Q over R, the same charge and the same radius. Potential at point C is also equal to K times Q over R. Look, potential at point A is equal to this expression. Potential at point B is also the same expression. Three of them. Therefore, the potential at point A, at point B, at point C, they are equal. Because of this circular surface is said to be equipotential line or equipotential surface. This surface is said to be equipotential surface. The other point is potential difference. This is the difference in potential between two points. For example, let's say this is a capacitor and another capacitor is placed here. Let's say this is a circuit. This is positively charged plate capacitor, negatively charged capacitor. Here distance between them. Now, in between these two plates, there is a potential difference. Potential is high in positively charged plate than negatively charged plate of the capacitor. Due to this, there is a change in potential between the two plates. Change in potential means the potential difference. Let's say this is plate B and this is plate A. The difference in potential between the two, which is equal to potential at point B minus potential at point A. Potential at point B minus potential at point A, which is potential difference. The last point is electric potential energy. This is energy. For example, if this is negatively charged, let's say this is positively charged plate and another plate here, negatively charged plate, field line is drawn from positively charged plate towards negatively charged plate, just like this. It is uniform in between two plates. Now, if a charged particle, let's say electron is placed in between the two plates, electron is accelerated towards the negatively charged plate in the opposite direction to the field. It is moving upward. Now, there is a force on the electron. So, the force on electron, which is electrostatic force, which is equal to the distance moved by electron, force is equal to electric field strength times the charge carried by electron. Let's say charge carried, simply electron, charge carried by electron. Now, the work done on a charged particle is equal to force times distance moved by a charged particle. The distance moved by a charged particle. Let's say this is simply magnitude of the charge, Q, carried by electron. So, EQ can be substituted instead of force. Therefore, let's say this distance is R. E times Q times R is equal to the work done on a charged particle. This work done is said to be electric potential energy. You know that Electric field strength is equals to potential difference times R. So substitute potential difference times R instead of electric field strength. Therefore, work done, which is equals to electric potential energy, which is symbolized by U, which is equal to, instead of E, substitute V over R times Q times R. Now R is cancelled by R. Electric potential energy is equals to V times Q. V times Q. This is electric potential energy. Therefore, electric potential due to a point charge, which is called absolute potential, equipotential line or equipotential surface, potential difference, and electric potential energy are not the same. They are not the same. They are expressed mathematically in different terms. Electric potential energy is the work done on a test charge to bring a test charge from infinitive. This is the work done on a test charge. Electric potential due to a point charge is the potential produced due to a point charge at certain distance from the charge. Equipotential surface, it is a surface. The surface which has equal potential is equipotential surface. Potential difference, the difference in potential between 2 points or 2 lines is potential difference. Electric potential energy is the energy possessed due to a particle which is placed in the field, in the uniform field or any other type of field, just like this, which is mathematically expressed as V times Q or EQR. EQR.